Hi there, this is Mike Lopez, and in this video we're going to be looking at sinusoids and radian measure. We've looked at sinusoids in the previous video, but perhaps we can have a quick look at what we mean by radian measure, because this is to do with pi, of course. Okay, so let's draw ourselves a circle. Obviously that is the diameter, which we call it d, and we'd like to go all the way around the perimeter of the circumference, as it's known, and that distance travelled is called c, the circumference. And some things to note: a circle of any size at all, when you take the ratio of the circumference and the diameter, you get a constant known as pi. Okay, so everyone's heard of that one. So pi, we can say, therefore, if we were to think about that diameter, I think, well, actually the diameter is 2 lots of the radius, and here's the radius here starting at the middle. Okay, so we can say, therefore, c over 2r equals pi. Therefore, we can say circumference is 2 pi lots of r, the radius. Okay, so what's this idea of a radian? Well, let's draw ourselves yet another circle. Okay, and in here we're going to draw a segment. Now this is a special segment because here's the radius, here's another bit of radius, here's the center. And it's special because this length here, this outer length of this segment, if we make it length r, then what we can say is this angle phi here is known as a radian. Okay, and what we can then also say is 2 pi lots of that length r is the same as going round the circle 360 degrees, and it's equal to the circumference, if you like, or equivalent to 1 circumference. And by the same token, we can therefore say, and let's do this in summary, 2 pi radians, or 2 pi times r if you like. Again, just summarizing what we've written above, 360 divided by 2, so we have pi radians is equivalent to 180 degrees. We can say divide by 2 again, pi by 2 radians is equivalent to 90 degrees. Pi by 4 radians, oops, too many s's. Pi by 4 radians is equivalent to 45, of course, degrees. Pi by 8 radians is equivalent to 22.5 degrees, of course, etc., etc. You can go to pi by 16 if you want. So that's basically what we mean by a radian. So it's the angle made, or the angle which is subtended by a section of the circle where the outer section here is r. So that makes it very, very special. Okay, what I would now like to do, once I scroll down, is to have a look at a power signal. So let's put this down then. So we've got a power signal, and I'm going to use an example. How about 15 angle 5 pi by 8. You can wrap all that in brackets. I can call it watts, okay, because power is measured in watts. And simple task now is to say, okay, what's the vertical component? The vertical component is quite simply 15 times the sine of 5 pi divided by 8 equals, now it's really important where you see pi's inside the brackets where you've got trigonometric expressions like sine, cos and tan, where pi's are there, you must have your calculator in radians mode. So radians mode for calculator. If you keep it in degrees mode, you're going to get the wrong answer. Okay, so if you put your calculator in radians mode, you should end up with 13.86 watts. And by the same token, the horizontal component is given by 15 times the cos 5 pi by 8, which comes out to be minus 5.74 watts. Let's see if we can draw this signal in terms of a phasor. So it looks a bit like this. Here's our axes. Here's 0 degrees. Here's 90 degrees. Here's 180 degrees. 270 degrees. And if you like, back to 360 degrees. Now, all of these points have equivalents in terms of radians. So, yep, that's 0. 90 degrees we've already indicated is pi by 2. 180 degrees we know is pi. 270 degrees it's going to be 3 pi divided by 2. And 360 degrees is 2 pi. And 2 pi is the same as 0 for a sine wave in terms of what its height actually is at those 2 points. Okay, now a signal like 15 angle 5 pi divided by 8 is going to look very much like this thing here. That's supposed to be a straight line. Okay, with an arrow on the end. And this angle here is 5 pi divided by 8. Okay, so what you could argue is if you divide all of this lot up, go round anti-clockwise there, obviously that's pi, so that's pi by 2, and pi by 2 is going to be the same as 4 pi divided by 8. So 4 pi divided by 8 is the same as pi by 2. So you can see we're going up in eighths. Okay, so there's going to be 4/8 along here and then another 4 along there. Okay, so that's the point where you've got 5 pi divided by 8. So if we were to now home in on this area here and have a look at the triangle which is produced, what we actually get is, here's our signal and it's of length 15. Okay, we'll put the 15 there because we're going to call that hypotenuse shortly. Why don't we complete the triangle, come down here, and what we'd like to do is to indicate what these two things are here. Okay, so minus 5.74 is along here. So in this world of phasors, when you're moving from right to left, the distance is negative. Okay, so that's got a length of 5.74. And the height, of course, is 13.86. And yeah, so it was a good idea to put a unit in, so watts and watts. Okay, let's now have a look at a current signal. So move into the current signal. Okay, let's use an example. IS, okay, the current signal, use the letters that we speak with, equals 20 sine t plus pi by 5. And what we'd like to do is find what the value of that current signal is, in other words, what's its amplitude when time equals 2 seconds. Okay, first thing to note, yeah, that's the amplitude, so that's the length of the phasor. This thing here is the frequency information. Okay, so amplitude, frequency information, and this lot here is the angle information. So when you're looking at pi by 5, what are you thinking of? Well, pi by 5, you know, pi is the same as 180, so it's equivalent to 180 degrees divided by 5, which sounds very much like 36 degrees. Yeah, good. Okay, so, you know, we have in your mind's eye what these signals actually mean. And again, all we need to do, and it's really important, calculator in radians mode is ultra important, otherwise you end up with the wrong answer, as we'll see shortly. Okay, so all I do, very simple, get the calculator out, do as it says, IS equals 20 times the sine t, well, we're making t equal to 2 here. Okay, so t is going to be 2, 20 times the sine 2 plus pi by 5. So we're in radians mode, we tap all that in, and we should arrive at 9.82. Well, it's current, so units are amps, so always put in units if there are units there. Okay, so it's really important, again, overemphasize this, put it in radians mode whenever you see pi appear anywhere in brackets. Okay, thanks for watching and see you in the next video.